those bits, which is where RDF comes into picture. And so this is kind of our view of graph interoperability. So it would be great if you could link one graph to another. Well, usually you already have that. It would be better if you could link an RDF graph to a labeled property graph or vice versa. And even better if you could kind of freely intermix RDF and LPG data. Also, it would be good if you could use Sparkle over LPGs, but now some of you will say, Sparkle, I don't care about that. A better situation would be where you could use maybe OpenCipher over RDF data. And even better would be if you could use any tooling for graphs on any graph data. We'll kind of do away with this rift that we have in the graph industry, so to speak. So Project OneGraph basically comes from this idea that we need to get away from this adversarial situation. We think that those are not particularly useful discussions. And like I said earlier, we'd like to be able to kind of use both RDF and labeled property graphs. And so this is a long-running effort in our team where we are building this idea of graph interoperability step by step and trying to understand exactly what does it mean in practice. So the motivation really is that if we look at the Amazon Neptune graph database, for the long time we have supported both RDF graphs and labeled property graphs, but only in a way where the users kind of have to choose first which one they want to use. And then this choice basically determines which query languages are available for them to use. And this confuses users and they don't know what to choose. And so we'd like to remove this source of confusion and make it easier for users, because sometimes the users, they choose wrong and then they start building something and later on they realize, oh, I made the wrong choice when it comes to graph type. And at that point, it's already very difficult to walk back that decision and switch. So really what we would like to see is kind of better alignment between the two graph models. But I want to be very clear that making RDF and labeled property graphs the same is absolutely not the goal of this project. We don't see any purpose in that because oftentimes people use RDF for different purposes than they use labeled property graphs. But combining the two is often also an attractive proposition. So the OneGraph model is essentially a graph meta model that is capable of accommodating various types of existing graph meta models. So RDF, and as it is emerging, the new RDF star model, labeled property graphs, and we kind of leave the door open for even other types of graphs that we might accommodate in the future. So, for example, the Wikidata flavor of RDF, which is slightly different from the standard RDF. We have no decisions on that, but we're basically not ruling out that we could do something like that in the future. The basic idea is that we would have a single graph, and then these constituent models would effectively be like lower dimensional projections of the universal OneGraph model. We do not want to translate between graph models. So OneGraph and views of that graph that would then let you think of that as RDF or think of it as LPG, and use all the tooling that you want on this data. Now, of course, this doesn't come without challenges. Luckily, most of the challenges that we face in building this model, they're rather simple. So there are syntactic questions. There are questions about scalar data types, for example, identifiers, things like that. Those are all pretty easy. When it comes to composite data types like lists, for example, we have a proposal how to change the way RDF treats composite data types, because currently in RDF you build the instances of composite data types from the graph structure itself. And while there's was a very good reason for doing like that, it makes programming with composite data types in RDF rather difficult. So our idea is to use typed RDF literals, essentially to encode the instances of composite data types. And we have a proposal on how to do this, kind of like a spec we've written, and we've just given it to W3C for consideration. I'll have a pointer to that at the end, so anybody who wants to take a look. But the main challenge, the really difficult challenge in the alignment is this, what we call the multiple edge instance problem. So basically, an RDF graph is a mathematical set of triples. And so the same triple can only occur once in the graph. And so at first, this seems like, well, why is that a problem? Well, I'll give you an example. So if I want to, in an RDF graph, I want to say that somebody named Liz married somebody named Dick. And then I want to annotate that, because in RDF, that's called a statement. So I want to annotate that, which in LPG terms would be to put an edge property on that. I want to say that that marriage happened in 1964. But then, of course, Liz goes and divorces Dick and marries somebody else and divorces them, and then marries Dick again in 1975. Now I can't do that because I already have that one triple in the graph that says that she married Dick, and that happened in 1964. So LPGs, of course, do not have this issue, but we can't simply break what's essentially one of the most fundamental features of RDF, and RDF was essentially built in a way that relies on this idea that the triples are unique. So this was the biggest challenge we faced. I'll come back to the solution of that in a minute, but we have now been sort of implementing this model, and Neptune Analytics, which is a new service that we launched last December. It already implements the OneGraph meta model kind of behind the scenes. We just don't make a big fuss about the fact that the OneGraph is there. Neptune Analytics currently only supports OpenCipher. We're working on the other query languages. But a couple of weeks ago, we launched the ability to now ingest RDF graphs into Neptune Analytics and then run OpenCipher over RDF. And so this is kind of like a very concrete step towards this OneGraph vision. Now, first of all, what this does is that in a way it sort of mitigates some of the kind of well-known shortcomings of Sparkle. You can do better path discovery, path traversal and path discovery using OpenCipher than you can with Sparkle. And then, of course, there are people who really don't like Sparkle, and now we can offer them OpenCipher as an alternative. We haven't yet fixed the schedule when we're going to introduce the kind of the remaining parts of OneGraph. And while we've been talking about kind of backporting some of the things from Neptune Analytics back to Neptune Database, there's no definite plans on any of that either at the moment. So unfortunately, I can't promise you anything new at this point. So here's some examples of kind of what OpenCipher over RDF looks like. And here on the left is a very simple Sparkle query. The query is a graph where we have information about airports and airline routes between airports. And so the query translates pretty easily. And one of the things you can notice here is that, first of all, we provide the way to declare namespaces, just like in Sparkle. And then you can use those namespace prefixes, but they look slightly different from the RDF qualified names. So we use 2 colons between the prefix and the name. This is basically to not break the OpenCipher parser. And in some ways, we haven't really sort of nailed down this. So if somebody has some other good ideas, we're happy to hear those, of course. But basically, everything works as you would expect. So here on the left is a query where we do a little bit of data modification. So we find these 2-hop paths and we replace them, or actually we add an edge that corresponds to the 2-hop path in the graph, and then we use those here on the right. We can now call the analytical algorithms that the Neptune Analytics provides. We can now call those on RDF data as well. So here on the right, we call PageRank on the graph, and that way try to find well-connected airports from the data. Okay, so I mentioned RDF star. So this is an ongoing effort at W3C. Initially, it was basically, the idea was that we'll make easier to use this so-called reification mechanism in RDF, because basically nobody likes it. And while it's an incredibly useful mechanism, because essentially you could do something like edge properties using that, but people don't like the mechanism, and so we set out to kind of simplify that. And initially we formed a what W3C calls a community group, and it issued its findings in December 2021. And then we after that we formed a working group, and in W3C working groups are the groups that can actually produce specifications. And we have been working on that. So now we come to about 2 years. We have now been working on that. And the end goal is to produce a set of specifications. So first of all, RDF version 1.2, and that's multiple specifications. One for formal semantics. There's various kinds of serialization syntaxes and so on. And then all the specifications for Sparkle, which now would be Sparkle 1.2. And this work is now ongoing. So now come back to the question of challenges. So RDF star actually addresses what I mentioned earlier, the multiple edge instance problem. Basically, by allowing you to introduce identifiers for what we call triple terms. And a triple term basically addresses a particular triple in the graph, but if you introduce separate identifiers for the same triple term, those are kind of considered to be individual occurrences of that triple, and then you can annotate those separately, and thus we could now build a model where Liz can marry the same guy twice, like I explained earlier. The identifier for a triple term, we call it a reifier. And if you introduce a triple in an RDF graph where this reifier is the subject, then this triple effectively is the equivalent of a value assignment to an LPG edge property. Now, RDF star in many ways goes beyond labeled property graphs in its expressivity. So one very obvious thing is that the new edge properties in RDF star, they don't have to have scalar values as their scalar types as their values, so they can actually be edges to other nodes in the graph. And thus you can kind of build something that looks a little bit like hypergraphs. But some of this expressivity has been kind of a point of contention in the current working group. There are some of us who are kind of more interested in the LPG RDF alignment than others, and particularly the idea that you could use a single identifier to identify multiple triples, which is an idea that has quite a bit of following in the working group at the moment, is something that essentially breaks the view that the statements about reified statements in this new graph are like edge properties in a labeled property graph. But I think we'll get through all that, and once the RDF star specifications are complete, we'll find that it is indeed a more expressive model, but it can accommodate labeled property graphs, which I think is a great thing. So then, of course, there's this question that what about the schemas and ontologies and all that, which on the RDF side are an important thing, but on the other hand, on the LPG side, not so much. And so our belief is that this basic interoperability provided by OneGraph could make it possible to use the RDF schema mechanisms for labeled property graphs, which essentially would mean that you could start building ontologies and actually kind of formally define ontologies for labeled property graphs. Now, of course, there's still, this is not something that is a done deal yet. I'm guessing there's still going to be something that shows up that may require some work. But the thing that worries me a little bit, that certainly requires some work, is that there is currently no good understanding how you could use edge properties or the more expressive sort of edges between edges, if you will, or edges from edges. How you could use those when you define your ontology. So first of all, there's no vocabulary for that yet. That needs to be defined. Of course, some people feel that doing something like this when you're defining an ontology is wholly unnecessary. And in a way, those people would be absolutely correct. But the pragmatic consideration is that edge properties are useful and thus desirable. And thus we want to accommodate those. Also, when it comes to schema definition, I've over the past year I did a little bit of work on adapting the PG schema proposal for RDF, and I presented that at the last Knowledge Graph conference, and I'll have a link later to the results of that work. And then finally, of course, there's this question of formal semantics. RDF has a definition for formal semantics, and that has served RDF quite well. And the RDF Star Working Group will have a definition of formal semantics for the new version of RDF. It will be backward compatible with the earlier version of RDF, and it will be defined in such a way that it allows RDF schema and OWL and the ontology languages to be built on top of it. So we should be good there. It formalizes the semantics of reification, this new form of reification, and that's something we never did earlier when RDF was originally built. Now, of course, some of you may think, well, what about named graphs? Are you going to address those? And the answer is no. At this time, we're not going to be addressing the semantics of named graphs. So named graphs will remain this this mechanism that people can use for whatever purpose they like. There's of course the question of what about formal semantics for LPGs, and I think that's sort of anybody's guess. Personally, I'm very interested in that whole topic, particularly because having the definition for formal semantics in RDF has really made RDF a lot stronger. And then, of course, there's so the RDF formal semantics is the thing that enables reasoning, or sort of symbolic reasoning in RDF. And the question of could we use those mechanisms over labeled property graphs? That's something that we would still need to kind of explore and experiment on. But I think that's a particularly interesting interesting thought of sort of taking LPG graph databases towards some type of deductive databases. Okay, so here's my summary. So OneGraph is ongoing, work continues, but the basic idea is that we provide this graph interoperability. And the first concrete step, of course, is this open cipher over RDF. More things are coming. RDF star, we will be completing a new version of RDF and a new version of Sparkle. It will definitely improve the RDF label property graph alignment, but like I said, some issues still remain, which we are working through. And then, of course, this question of schemas, ontologies, reasoning, all that stuff that's kind of commonplace stuff on the RDF side that still needs work, whether that's LPGs or OneGraph more generally. So I'll make these slides available so you don't have to write down these URLs, but there's a couple of things here that might be interesting. There's a recent blog post on the AWS database blog that talks more about RDF and the use of OpenCipher with RDF. We published an article in the Semantic Web Journal that essentially introduces OneGraph and particularly talks about why it's difficult to build a model like OneGraph. We published something at the European Semantic Web Conference recently on these composite data types. And there's also pointed to that work that I did on adapting PG schema for RDF. Happy to answer questions, and there's my email address. If you want to ask questions later, I'm happy to answer them now or later, whichever suits you best. Thank you.
Thank you. Any questions?
Either everything is completely clear or I'm just not hearing the question.
No, the question's coming. It's Alistair here, Aura. I
Yes.
wanted to make a couple of comments. One is on this question of your reifiers. So if you viewed these reifiers as being the identifier of a group of triples, any group of triples, surely then I can decide to use a reifier for a single triple, and then it
absolutely
has this use that you want for edge properties. But why deny the more general use? And to extend that one step further, I guess a group of triples is a graph. Yes. If I have a set of triples, I have a graph. Yeah. So why can't you extend this or generalize this and just say we can have an identifier for a graph, and we can make a statement about a graph, and then the edge property is a very special case, which is very useful. But the general case is also, I would have thought, very useful, actually.
It absolutely is incredibly useful. You're absolutely right about that. Now, the problem is this. So first of all, if I use a single reifier for a set of triples, there's no kind of equivalent on the property graph side of that.
And when I talk to people suggesting, hey, how about this? Most people have found it very confusing. The confusion is made even worse when people realize that, wait a minute, you have named graphs in RDF, and that's already sort of a name identifying a set of triples. So why isn't, when we reify a number of triples, why isn't that the name graph? And the reason why we didn't touch name graphs is because name graphs, when they were introduced, there was no semantic theory introduced for name graphs, and that has led to people using them for various kinds of purposes. And we didn't want to basically sort of usurp the name graph mechanism for our purpose, because people may have other purposes for using name graphs. But you're absolutely right. I mean, this is a particularly useful mechanism, and I think that if I was only doing RDF, I would say absolutely yes, let's do this. But because I want this alignment between RDF and property graphs, and there is no kind of counterpart of that multiple, triple, single reifier situation on the property graph side, that's why my feeling is, and the whole Neptune team's feeling is, that it will just confuse people.
But
so that's kind of like a point of contention.
Yeah, but that latter point confuses me, because one of the things that we did in GQL is to try and break away from the Cypher assumption that there is a single ambient graph, and to say there are named graphs, and therefore we can, in principle, do things like project a differently named graph, or have a graph which is actually a merge with another graph, it's a view, and all of those kinds of things, in order to be able to actually get away from all these limitations that exist in the Cypher LPG model. So it feels to me like that direction is actually, it's unfamiliar to Cypher people, but it's not unfamiliar to the label property graph community and people who are thinking about the direction it should go in. Just
okay, well, that's no, that's an excellent comment, and in fact, I'm very happy to hear that comment, because it makes me think that maybe we don't have such a problem in trying
that was
to
what I was
get
wondering
people
about
to
when I was
agree on
listening
things.
to your explanation of that. Is that really such a big mismatch? I mean, the other thing that I think there's a lot of pressure for in the LPG, sort of forward-thinking, parts of the LPG community, people are thinking about, the sort of standardization issues and so on and so forth, is the ability to have edges that, depart from or go to edges, for example. We have a concrete problem when we're trying to build a graph model that would represent the information about a schema for, we want to actually be able to have the schema represented as a graph. And one of the issues is we want to make mappings and make statements about edges in a schema graph. So if you imagine you have a schema graph where an edge represents an edge type and a node represents a node type, there are statements that must be made about the edge type, and we can't represent that as a graph.
Yes.
Yeah. So, but we'd like to be able to, and I think that.
Okay. Well, this is.
There's very much there's some convergence, I think, possible here. I mean,
yeah. No. I mean, I think this is some of this. I guess I've sort of missed, but this is very good. This is actually very good news, because it makes me think that we actually have an opportunity for even greater alignment than I had imagined. So
yeah. So I mean, I return to my point from the Knowledge Graph conferences. I think we need to talk more.
Yes, we do. Yes, we absolutely need to talk more. So let's make a point of doing that.
Cool. No, but this is very interesting stuff, and I think that
well, we're very happy. We're pretty darn excited about this, because we're so fed up with these kind of religious wars.
So just a couple of other points. Formal semantics. Are you familiar with Leonid Libkin's work on formal semantics?
Yeah. So that's definitely work in the right direction. Yes.
Yeah. So there is stuff going on there, and I think this. I had one specific question about your view on schema. You mentioned OWL. You mentioned RDFS. What's the story from your perspective about Shackle?
Yes, good. That's a good question. So Shackle actually would be maybe the best suited as a schema language to use over an LPG, because Shackle is based on the closed world assumption, whereas RDFS and OWL essentially rely on the open world assumption, and that confuses the heck out of regular database people. It's absolutely important for knowledge representation, and particularly because we originally set out to do this 25 years ago, to do this in the context of the web. But I think that for regular database application, Shackle actually would be a much better schema language. And I'm sort of thinking that pretty soon I get to try Shackle over LPG data. Not long, and I get to do that. And in fact, in my work to kind of make the PG schema sort of more RDF friendly, I actually implemented that by translating PG schema into Shackle.
Mm-hmm. I think there's a reconciliation problem with GQL graph types, because the whole way in which that proceeds is kind of, yeah, you can represent it in Shackle, but it's a different paradigm. So I mean, I'm personally unconvinced about making Shackle the way of describing schema for property graphs. But I'm sort of, what I am convinced about is I think it's a very important source of features or ideas. And
well,
that's something that needs to be looked at. But
I mean, ultimately, Shackle is just a way to introduce constraints that limit your graph.
Yeah.
So, so if you view a schema as a means of sort of limiting what the graph can look like, for purposes of whatever purposes you might have, validating your data or whatever, then by all means. When you have other purposes for schema, then we need more.
Anyway, thanks. Yep.
Yep. Thank you.